Today we are into part 9 of our course in software project management. So far we have seen project management processes like project planning, project monitoring and control, and project initiation and project closure, etc. So they are main processes for any project management, including software project management. Apart from that, in software project management, you also have other processes going on, and they are essentially termed as software engineering processes. So they are also known as software cycle processes. Software lifecycle is a series of processes which are used to build software products. These are these are also termed software lifecycle models. The main software lifecycle models include Waterfall Model and many varieties of iterative models like Scrum, Extreme Programming, etc. Waterfall model is the classic model for software development where each development process follows the preceding process without the room to go back, like a waterfall model, where water falls from top and goes down without ever coming back to the top. Software building starts when a requirement gathering is done. From requirements, a software design is made. From software design, software construction starts. So, uh, in the waterfall model, uh, when a project starts, so the software engineering process starts like first, the requirements are gathered from users by the project team, and based on the requirements, software design is made, and then from this design, software will be constructed by writing source code, and then testing of the product will be done. So in waterfall model, just like in a waterfall, the water flows from top to bottom. In a waterfall model, the process flows from the requirements management, and then to design, then to construction, then to testing. And so, like water never going back, it just flows in one direction. So in waterfall model, these processes also follow uh, flowing pattern. That is why it is known as waterfall model. Apart from waterfall model, there are other models also, and mostly they can be grouped and known as agile models. There were some shortcomings in the waterfall model, so these agile methods were developed. So we will discuss about these uh, software engineering processes, also known as life cycle, software life cycle processes, and within a model. So model is like waterfall model or agile model like Scrum or extreme programming, etc. So by using software engineering, we get productivity gains, and how these gains are achieved, because actually we will be using software engineering and models in building a software product. So these are the core processes in any software project, and why the software, what are the benefits of software engineering in providing productivity gains. So you can do code reuse. So code reuse means if there were already some software components built, so the code written for those components you can reuse. Then maturing software engineering. Okay. Then productivity tools. Software engineering provides productivity tools for the people to work on a software project, then automatic code generation. So some software engineering tools provide facility to generate code automatically. That means uh, if you are designing a software product, so from that design, some source code can be generated automatically. So these are the things which help in providing productivity for the project team in building a software product. Now, software life cycle in a waterfall model. So, like we discussed earlier, we have requirements, and based on the requirement, a software design is made, and based on the design, software will be constructed, and the built software then will be tested, and then it will be released. And finally, when the software is in use, and if any defects are found or any enhancement needs to be done on the product, then it can be done using a maintenance project. Contrary to waterfall model, iterative models allow the software building work to go back so that any part of the software can be rebuilt using rework. So the shortcoming of waterfall model is that you cannot go back. Yes, if you are at the construction phase, then you cannot go and do some design. So the iterative models actually allow you to do so, and actually how it is done we will see later. Models like Scrum and Extreme Programming in fact try to minimize the rework by using iterations. In one iteration, a small set of features of the software product are taken and they are completely built in a short period of time, say 1 week. Once it is reviewed and okayed, next set of features are taken. This way, the complete software product is built over a long period of time. Iterative models differ from each other by the degree to which the iteration takes place. In a Scrum model, the iteration is complete, whereas in some model like a rational unified process model, the iteration is not complete. The iteration takes place within you can say a phase in the software development cycle. But in Scrum or extreme programming, iteration goes from the requirement to design to construction to testing, and the complete all these activities, all these software engineering activities are done in each of the iteration. So this is the thing about the iteration and the difference in the iterations in different models. In waterfall model, you can use concurrent engineering, and how it is done is like the construction phase is a very intensive and a very large uh, effort required in building or writing the source code. So suppose we have the requirements, and then based on the requirement, design is also built for the software product. Now this design can be broken into many parts so that different software developers can take that part of the design and work on it. So that the whole work can be broken into parts and can be done concurrently. When people do the work concurrently, that means the time required will be shorter. Like if one person was supposed to to write all the source code, it will take a lot of time for that person to do. But if that same work is taken and given to say 5 people, and 5 people work on the different parts of that construction work, then and they are doing it simultaneously, concurrently. So the whole effort of building the product, the time required to do it will be short. So that is the use of concurrent engineering in software lifecycle. Then here are the work products from different stages in the software lifecycle. So from the requirement phase, we have requirement specification document. So the people who gather the requirement and create requirement specification, the end product is a document which is known as requirement specification document. And from the design phase, we have the product model, or you can also say product design. And from the construction phase, we have untested product, and it was developed using writing the source code. And currently it is untested. It will be tested later. Then testing phase. In the testing phase, the untested product is tested and ensure that it passes the quality requirements. And then in the release phase, uh, you we get the accepted user accepted product, user materials like manuals and documentation and training of the user, etc. Then in waterfall model, you can introduce quality gates to get a better software product. And how these gates are implemented is like when in the after the requirement phase, some exit criteria will be fixed, and the requirement specifications will be tested and found if they are okay, they are fine, they do not have any problems. Only then the specifications will be released, and the design people will work on these requirement specifications to create design. Again, there will be exit criteria, there will be quality gate, and the design will be checked. Huh. And then construction phase. In the construction phase, there will be again exit criteria, and the source code which was written will be checked to see if there are any defects. If there are any defects, they will be fixed, and only then the next phase will start. So essentially, at the construction phase, some testing can be done by the developers, like unit testing and integration testing, and the remaining testing will be done at the system level by the testing team. So in the testing phase, the testers will test all uh, the software product based on the requirement specification and software design. And when the product is tested thoroughly and it passes the quality requirements, only then it will be released. So in the release phase, it will go to the release phase. So these are the purpose of quality gates and how they are implemented. Waterfall model poses significant risk in terms of rework which may have to be done when requirements get changed, which is often. The iterative models offer attractive benefits in this regard. Most of the software projects where products are built for newer technology, like those for social media, software for gadgets like mobiles, camera, etc., iterative models are better suited. Due to increased pace with which technology gets obsolete and newer technology takes its place, iterative models allow the project teams to incorporate newer technology. So iterative models are now more used on software projects rather than the waterfall model because they have the benefits of reducing the risk. And the main risk on a waterfall model is that suppose the project team estimates the product will be built in 1 year's time. So the customer or the user will be able to see the product only after 1 year. So it is a big time gap, and during this time, the customer and user do not know what will be the product like. And at the same time, the requirements get changed due to changes in the market or changes in the requirement of the users. So those changes need to be incorporated, and when this happen, it the project execution gets impacted. So it is better to have a model where you don't develop the complete product. Instead, you develop only a small part of it, say in 10 days or 20 days, and get it checked by the customer and end users. And if it is fine, then you again build one more part of the product, integrate it to the existing product, and you keep building the parts of the product in this fashion. And in this case, the users every say 20 days, if the iteration cycle is 20 days, so after every 20 days the user is able to see the product features. And if they say some the user has some requirement currently, but say after 3 months time that requirement is changed. So since the project team is not working on that feature, so it doesn't matter. When the time comes, the change requirements will be taken, and the product features will be created based on these change requirements. So that is the advantage of the iterative and agile models. However, waterfall model is still better suited for products where a massive backbone is needed to build a software product. Software applications for businesses like ERPs, operating systems, etc., are examples. In such applications, you need to build at a very fast pace. At the same time, the size of the product is very large. So in such cases, a small team cannot deliver a software product because a small team will be able to create only a small set of features, but and so the total time required will be very large. But suppose a ERP product needs to be developed in 1 year's time, and the size of that ERP product is say 200,000 lines of source code. If you have a small team, it cannot build this large product in 1 year's time. But in waterfall model, you can build such a product by employing a very large project team. So in such cases, the waterfall model is a better model. So this was all about introduction to the life cycle models for the software projects. In the next session, we will see requirement management in detail. So thanks for your time, and bye for now.